Hello everyone and welcome back to my YouTube channel. I hope that you are doing well. So here I am again with our chapter triangles important for SSLC, that is class 10. So prior to this I have already made videos on all the theorems, mainly the three theorems which are important from the chapter triangles, as well as in the previous section I also solved the 6.1 exercise along with its basics introduction. Okay, so in this video, okay, I will be solving the second exercise. If you are following the NCERT textbook, it will be mentioned as 6.2, or if you are following the Karnataka State Board book, it will be mentioned as 2.2. okay, based on the chapter number. So this is totally based on BPT. Okay, what is this BPT? As you all know, basic proportionality theorem, or it is also called as Thales theorem. Okay, so this theorem may be asked with proof for 5 marks, or else if they are not giving any problem on that, they will definitely if they are not giving any theorem related to BPT, then they will definitely ask a question based on this. Okay, either for 1 or 2 mark. So you should be aware of that. You should be aware of how to solve the problems given on BPT and how to identify that the question given is of BPT or Pythagoras or areas of similar triangles. That all we are going to discuss in this video. Okay, so stay tuned till last. Learn the problems, how to solve them, and learn it from the basics. Also, if you find it useful, do like it. Don't forget to comment, share, and subscribe the channel. Also press the bell icon to get the notification of my videos. So let us start from the basics. What is this BPTC? BPT means basic proportionality theorem. Okay, so what is its statement? Its statement says that if a line is drawn parallel to one side of a triangle, so let me draw a line, a triangle first. Imagine this is a triangle ABC. Okay, they've said if a line is drawn parallel to one side of a triangle, let me take the side BC and draw a parallel side to BC. Okay, and I will name this as DE. So D is the line which is drawn parallel to the side BC. Okay. Then the other two sides, which are the other two sides? That is AB and AE, AC. Correct. Again, let me read it again. If a line is drawn parallel to one side of a triangle to intersect the other two sides in two distinct points. Okay. So these are the two distinct points where it is intersecting. The other two sides are divided in the same ratio. Now these two sides, okay, AB and AC, they are divided in the same ratio. So AD by DB is equal to AE by EC. So this is the BPT. Okay, so this line was parallel to BC, so the rest two sides, okay, they will be divided in the same ratio. Remember, now if the line was parallel to this side, it means what? These two sides will be divided in the same ratio. Similarly, if it was parallel to this side, then these two sides will be proportional to each other. Understood? So that is BPT. And also we can write this AD by AB will be equal to AE by what? EC. AE by AC. This is also BPT. Okay, extension of BPT you can say. Now we should also know about converse of BPT. What does it says? If a line divides any two sides of a triangle in the same ratio, okay, in the same ratio, then what's they have written here? Okay, then the line is parallel to the third side. Okay, so as per them, if a if a line, it divides any two sides of the same of a triangle in same ratio. Okay, this is the line, imagine, and this is what it's doing. It is dividing two sides. These are the two sides of the triangle in the same ratio. For example, ABC, this is DE. So this line is dividing AB into AD and DB, and AC into AE and EC. Okay, and these two are in the same ratio. Then the line is parallel to the third side. Then this line is definitely parallel to the third side. Which one is that? BC. So we can say D is parallel to BC. So this is the converse of BPT. BPT is, if this is parallel, then the other two sides are proportional, and converse is, if the other two sides are proportional by a line, then that line is parallel to the third side. Okay, so you have to remember these two to solve the problems of exercise 6.2. Okay, so I hope you have understood it. So let us start solving the problems. They are very easier if you understand them. Okay, so here is our first question. So question number 1 says, in figure 6.17, 1 and 2, okay, so this is first and second figure. D is parallel to BC. So you can see here, this is triangle ABC. Again, this is also ABC. D is parallel to BC. Find EC in 1. So here you have to find this EC, and AD in second. Where is AD? Here. So if you look at the first figure, okay, there DE is parallel to BC. So can I say this as per BPT, AD by DB, correct? AD by DB will be equal to AE by EC, right? We need to find EC. So we'll keep it as it is. Others, they have given 1.5. So substitute. DB is 3, this is 1, and this is EC. So on doing cross multiplication, we'll get EC is equal to 3 into 1 divided by 1.5, which is equal to 1.5 into 2 is 3. So EC is how much? 3. It is 2 centimeter, correct? Now similarly, in the second figure, again D is parallel to what? BC. So once again, AD as per BPT, AD by DB will be equal to AE by AC. Now substitute the values. AD is unknown, but we know DB is 7.2, AE is 1.8, and this is 5.4. So on doing the cross multiplication, we will get 1.8 into 7.2 divided by 5.4. So if you look at it carefully, all of them are the tables of multiples of 18. If you remove the decimal, if you are not looking at the decimal, you can see this as 18, this as 72, this as 54. So use the same trick. So 18, 3 is how much? 54, correct? And here 3 2 is a 6, 3 4 is a 12. So this is 2.4. So therefore AD is how much? 2.4 centimeter. So using BPT you can solve such problems, and this type of problem you may get for 1 mark section. Okay, now coming to question number 2. So in second question, what have they given? See, E and F are points on sides PQ and PR respectively of a triangle PQR. Okay, so imagine there is a triangle PQR like this. Okay, PQR, and E and F are points on PQ and PR respectively. So E is on PQ and F is on PR. Now they are the points on sides PQ and PR respectively of triangle PQR. Okay, now they have given what? For each of the following cases, state whether EF is parallel to QR or not. So EF is parallel to QR or not, we have to say. So when will these two be parallel? When, since this is parallel to third, the other two sides should be in the same ratio, correct? What is that side? As per converse of BPT, PE by EQ should be equal to PF by FR. Now look at here, they have given PE, EQ, correct? PF, FR. In the second also PE, EQ or Q is same, and PF, RF same, PQ, PR. Now in the third they have given what? PQ, PR. So where is PQ? This is PQ and PR is this. They have given PE. So there you have to take PE by PQ and PF by PR. So let me solve the first one first. Okay, let me substitute as per BPT, converse of BPT. We can say to prove whether they are equal or not. So this is 3.9 divided by 3, which is equal to 3.6 divided by 2.4. So this can be divisible by 3, correct? So 3 ones are, and this is 3 ones are. So this is 1.3, but here they can be divisible by 2. So 1.2, and this is 1.8. Now again they are divisible by 2, so 0.6. Here you will get 0.9. Now again divisible by what? 3. So 0.2 and 0.3. So this is 0.3 by 0.2, which is not equal to LHS. So we can say कि EF, in this case EF is not parallel to QR. You can directly write that. Okay. Now the second one. Again PE, QE. So directly substitute 4 by 4.5 equals to 8 by 9. You can do in this case also. You just multiply do the cross multiplication. So 9 4s are 36, and here how much? 8 5s are 40, 4 is carry, correct? And 8 4s are 32 plus 6 is 36. See, both LHS and RHS are equal, so we can say yes, here EF is parallel to which one? QR. Second case we can say. Now coming to the third case, let me write it here. See here, PQ is given, this complete side PQ, and PR, this complete side is given, but here they have given PE, only this. So using again PE, okay, by PQ, and that will be equal to what? PF by PR, okay, or RP. So PE is how much? 0.18 divided by PQ is how much? 1.28, which is equal to PF is how much? See, 0.36, and this is PRP is equal to 2.56, right? So if you can multiply throughout by 10, see, because since decimal is there, so multiply and divide by 10. So here you'll get 18 by 128, and here you'll get 36 by 256. Okay, so are they equal? If you solve them, what will you get? So both of them are divisible by 2, correct? Here 2 9s are, here 2 6 are 12, 2 4s are. So you'll get 9 by 64, and here if you look 2 18s are 36, and here 2 1s are 2 2s are 2 8s. Again 2 9s are 2 64s. So RHS also you are getting the same, right? So since both of them are equal, we can say yes, we can say that EF is parallel to QR. So this is how you have to check. Understood? So they are very simple. I hope you got it. Now moving to the next question. So coming to question number 3. In figure 6.18, where is it? Here. So this is the figure. LM is parallel to CB. Okay, this LM is parallel to CB. Okay, and LN is parallel to this. LN is parallel to what? CD. Okay, prove that AM by AB. Where is AM? Here. AM by this AB is equal to AN by AD. So if you look at them, this is one triangle. Let me write it first. Okay, it is like this. Sorry. Yes. So here this is A, L, M, B, C, and here since LM is parallel to BC, can we write as per BPT? AL by AC we can write, correct, and that will be equal to AM by AB, right, as per BPT, correct. Now similarly, and take this as 1. Similarly, the next figure, if you see, just separate it. This is A, L, C, and this is N and D. And here, since Ln is parallel to CD, can't we write AL by again AC is equal to AN by AD, right? This is equation 2 as per BPT, correct? So if you look at these 1 and 2, equation 1 and 2 are equal. Why? AL by AC. Here also AL by AC. Both of them are equal. So we can write AM by AB equals to AN by AD. Right? Because if two are equal, these two are equal, the RHS should also be equal. Therefore, we got the answer. Right? That's what they have asked. So it's very simple. Just you have to make it into two part and write it. It's very simple. Okay. Now moving to question number 4. I hope you are understanding it. Okay, the fourth one says, okay, in the fourth question they have given in figure 6.19. Here is 6.19. DE, where is DE? If you look at it carefully, this is DE, is parallel to AC. Okay, so this is AC. So this will be the triangle, right? So let me write it separately. So you have to always write separately, then only it will be easy. B, this is A, C, and this is D, E. Okay, this is one case. And second case, if you see here, let me erase this. Second case is what? DF is parallel to AE. This DF is parallel to AE. So let me write this separately like this. Okay, this is B, this is D, E, sorry, this is F, and this is A, E. Okay, now they have given here DE is parallel to AC, and here they have given DF is parallel to AE. They have asked to prove BF by FE. If you look at here, where is BF? Do we have BF? This is F, yeah, BF. This BF by FE, this is equal to BE by EC. This we have to prove. So again, if you look at here, these two is common on both the triangles. So we can take the advantage of that. See, since D is parallel to A, as per BPT, we can write BD by DA is equal to what? BE by EC. Correct? As per BPT, you can write the reason. Similarly here, since DF is parallel to AE, the other two sides will be like this. BF by FE is equal to what? BD by AD as per BPT. And now this is your second equation. This is your first. So both 1 and 2 are equal. Why? See here, BD by AD is also here BD by AD. So since they are equal, we can write BE by EC is equal to what? BF by FE. That's what we had to prove. Hence, proof. That's all. Isn't it simple? Yes. So you have to just observe the questions properly and you can do it. Okay. I hope you are getting it. If yes, kindly do press the like button and don't forget to share it with your friends. Okay. Moving to question number 5 now. Okay. So what does fifth one says? In figure 6.20, okay, this is the figure. D is parallel to OQ. So where is DE? Yes, here. DE is parallel to OQ. So this triangle will form, correct? So always whenever you read the question, just draw the triangle. Okay, this is P, this is E, this is Q, this is D, this is O. And they have said what? DE. Okay, this DE is parallel to OQ. Okay, and next is DF is parallel to OR. So let me erase this now. DF, where is DF? Yes, here. DF, this is DF, is parallel to OR. Okay, so this triangle POR. So let me write that here. Correct? This is P, D, F, O, R. Here they have given DF is parallel to OR. Now what you have to prove? Show that EF is parallel to QR. Okay, where is EF? Yes, in this figure EF is this one. This EF is parallel to QR. So when will this be parallel? See, using converse of Bpt, these two will be parallel only when these two sides are proportional, correct? So we have to prove what? PE by EQ is equal to PF by ER. So let us use the given data. As per this data, we can write PE by EQ is equal to PD by OD, correct? Similarly, as per this data, we can write PD by OD is equal to PF by FR, correct? So this is 1 and this is 2. So now since 1 and 2 are equal, correct? Why? Because PD by OD, here also PD by OD, both of them are equal to PE by EQ and PF by FR. Now see, that's what we needed, right? PE by EQ. PE by EQ is equal to PF by ER. Therefore, as per converse of Bpt, we can say since the other two sides are proportional, the third side will be parallel to the intersecting line. Therefore, EF is parallel to QR. That's all. It's very simple, isn't it? Yeah. Moving to the next question now. So question number 6. I hope you are enjoying it. If yes, do press the like button. Don't forget it, yeah. Do it. Sixth, if you see in figure 6.21, where is it? Yes, this figure. A, B, C are points on OP, OQ and OR. Okay, where is this? A, B and C are points on OP, OQ and OR. Okay, respectively, such that AB is parallel to PQ. Again, AB, where is AB? Here. AB is parallel to PQ. Okay, so got one triangle? Yes, that's all. So write that triangle. Let me write as it is. Okay, so this is O, A, P and this is B, Q. And here they have given AB is parallel to PQ. Okay, good. Next. And AC is parallel to PR. Where is AC? Yes, AC is here. Here, AC is parallel to PR. Means you'll get this triangle, correct? So let me write that also. It is something like this, correct? This is O, C, R and this is A, P. So you can write here what they have given. AC is parallel to PR. Now you have to show that BC is parallel to QR. Where is BC? Yes. So this is BC. This is parallel to QR. When will this be parallel to QR? When this, if you look at this triangle, see properly. It's all about observation. Okay. When these two sides are proportional, correct? So let us see using the data, can we do it or not? So using this data, AB parallel to PQ, can I write OA by AP is equal to OB by BQ? Yes, it can be. Similarly, here we can write OA by AP is equal to OC by CR. Right? This is 1 and this is 2. As per Bpt. That you have to write it always as per Bpt. Now see, in both of the cases OA by AP are equal. So as per 1 and 2, since they are equal, can we write OB by BQ is equal to OC by CR? Now since these two sides are proportional, we can say yes, BC is parallel to QR as per converse of Bpt. That's all. It's very simple. I hope you too have understood. Just write the reason. That's all. Okay. Now moving to 7th question. But before that, what you have to do? Do it, man, if you have not done it yet. Moving to 7th question now. So 7th question is here. What have they given? Using theorem 6.1, it means Bpt. Okay, remember, using theorem Bpt, prove that a line drawn through midpoint of one side of a triangle parallel to another side bisects the third side. Okay, recall that you have learned, that you have proved in class 9. Okay, leave that. Just refer this. Prove that So first of all, you have to write a figure. Okay, uh, write a triangle first. We'll name ABC. We'll name this as ABC. Okay. Now read the question. Prove that a line drawn through midpoint of one side of a triangle, midpoint of one side of a triangle, parallel to another side, okay, bisects the third side. Prove that a line drawn through midpoint of one side of a triangle, okay. See, if a line is drawn through midpoint, so let me draw a line midpoint of, for example, AC. I'm drawing. This is the point D. Okay, now a line is drawn through midpoint of one side of triangle, and that line is parallel to another side. So it is parallel to another side. For example, let it be parallel to which one? BC, like this. Okay, so let it be CD, DE, DE. Okay, then parallel to another side bisects the third side. Okay, so see, it was passing midpoint of AC. Okay, means AD is equal to DC, first condition, and it was parallel to second condition. What? Parallel to the other side means ED is parallel to BC. This is also data. We have to prove that it bisects the other side also. The third side, which one? This. So we have to prove that AE is equal to EB. If this is midpoint, definitely these two sides will be equal, correct? So this is what we have to prove. This is to prove, and this is the data. Okay, so using this data we can write, since ED is parallel to BC, as per BPT, can we write AE by EB is equal to AD by DC? Yes, we can write. And since AD by DC are same, can I write AD as DC as AD? Right, because it is in data, they are equal, they are formed by the midpoint, so both of them will get cancelled and will get 1. So on doing cross multiplication, we'll get AE, here is 1 by 1, so AE is equal to ED, hence proof. That's what we needed to prove. Since these are equal, we can say E is the midpoint of AB. That's all, simple. This is what we have to do here. Okay, I hope the concept is clear and you have understood. Moving to the next question. So question number 8, what does it says? Using theorem 6.2 means converse of Bpt. Okay, here they was to use the converse of Bpt. Prove that, but in exam you will not get all this, you will get only till here if they asked. Prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. So again, this is the triangle. Imagine, let ABC is a triangle. Now they have given what? Prove that the line joining the midpoints of any two sides of a triangle, midpoints, let me take midpoint as D, midpoint of AB as D and midpoint of AC as E. Okay, then this line, if it joins the midpoint of the other two sides, then it is parallel to the third side. So data what they have given, data is D is midpoint of AB, correct? Therefore AD will be equal to what? DB. Similarly, E is midpoint of AC, so we can write AE equals to EC, correct? Now what we have to prove? To prove that D is parallel to BC, how can we prove? So using BPT, let us write. Can I write using BPT? I can write here AD by, shall we use BPT? Why? Because they have not given anything, right? Because we need to prove D is parallel, so we cannot use BPT. Okay, but instead of that, can I write here? See, I can simply write here AD by DB. Since both of them are equal, like I can write AD by AD, which is equal to 1 by 1, correct? Similarly, AE by EC, since they are also equal, here they can also be written as one by one. So equation 1, equation 2. Here both 1 and 2 are equal. So can I not write AD by DB? That is equal to what? 1. Here also equals to 1. So since both of them are equals to 1, we can write, yes, DE is parallel to BC. Why? Because this is the converse of BPT. Correct? The other two sides are in the same ratio. Then definitely the third side is parallel to the last to the given line. Okay. I hope it is clear. Moving to the ninth question now. So question number 9 is, you can read it here. ABCD is a trapezium in which AB is parallel to DC. Okay, and its diagonals intersect each other at point O. Show that AO by BO is equal to CO by DO. Okay, so let me write a trapezium first. Okay, they've given a trapezium. In a trapezium, opposite sides are, one of the pair of opposite sides are parallel and the other pair is not parallel. Okay, so this is a trapezium. Imagine AB, and they've given AB is parallel to CD. Okay, you can write CD over here or here, it's not a problem. And the diagonals intersect each other at B. So DB and AC, they are the diagonals and they are intersecting at point O. Now show that, this is the data given, you have to show that AO, this is D, okay, AO, where is this? AO, here, AO by BO, this is BO, is equal to CO by DO. This is what you have to prove. So whenever you get question on the basis of this trapezium, what you have to do is, you have to always draw a line parallel to other two sides AB and CD. Which line you can draw? You can draw a construction, you can do a construction like this. Okay, you can name this as X, Y. Okay, so this is what you have to do. So you can write draw XY, okay, through O, such that it is parallel to what? Yes, it is parallel to CD, or it is also parallel to AB. That is also fine. See, now why we have taken that, we'll take two triangles now, such that we'll get AO and BO in one side. So if you look at here, AO is here, correct? And what about BO? BO is in this. So what we are going to do? Simple. See here, we'll take two triangles now. This one, DOP. Okay. So in triangle DBA, here you can see XO is parallel to AB. Correct? So since it is parallel, we can write, what can we write? Yes, we can write DO by OB equals to DX by XA. Similarly, in triangle from this side, look at here, this. Okay. Yes, in triangle CAB, here OY is parallel to AB. Correct? So I can write here CO by OA is equal to CY by YB. Isn't it? Now see. Yes, so do we get anything equal? No. So we need to change. Yes, see here. I think, yes, look at here. First triangle we took this one, correct? Isn't it? And what was the common? This line was common, isn't it? XO was parallel to CD. Where is it? Sorry, AB. Now similarly, we have to take the same thing, but in this direction. Okay, here XO will be parallel to DC. Okay, then only we will get what? AO by OC will be equal to AX by XT, not this case. Okay, so now see, these two will be equal, correct? How can they be equal? This, as per BPT, we can also write this as OC by OA equals to XD by AX, correct? Now see, look at this and this. If you compare both of them, this is also dx by xa is equal to LHS. So therefore we can write DO by OB is equal to OC by OA. But we need to prove what? It is OC by DO. So just do the cross multiplication here. So you will get in the RHS, you will get OC by OD or DO, both are same, equals to OA by OB. That you can also write as AO by OB, hence proved. So there was a minor mistake which you have to rectify. Okay, so you have to take the same parallel to both the side. Once you are taking from DAB and the other ADC. Got it? In the both case OX is parallel. That should be common, only then you can solve this. Okay, I hope it is clear. Now moving to the last question, and it is similar. Yes, so question number 10 says the diagonals of a quadrilateral ABCD intersect each other at point O such that AO by BO equals to CO by DO. Show that ABCD is a trapezium. So it is similar question. So we have to draw a rough figure of four sides like this. Okay. Okay. And they have given this as A, B, C, and D. And the diagonals again AC and DB. They are intersecting at O. And we have to show that what? AO such that, sorry, they have given AO by BO, okay, these two, AO by BO is equal to CO, this is CO by OD or DO, and we have to show that ABCD is ABCD is trapezium. So in a trapezium any two sides will be parallel, correct? But at present we don't know whether they are parallel or not, so we have to prove that. So again use the same concept, draw a line, you can name this as XO, okay, join X, extend it till here, Y, okay. You have to do this one, this is very compulsory, or else you can just join this much till O. Let me not join till X, Y, let it be till O, okay. Now see, and this is parallel to what? Yes, you should make this as parallel to AB. Okay, this is parallel to AB. So what we will get from this triangle, that is DBA, will get DO by OB is equal to what? DX by XA. Okay, this is one. And the second data is given what? The data is given as here. The data is AO by BO is equal to CO by DO. Now see, if I do the cross multiplication, I will get DO by OB or BO equals to CO by what? AO. This you could take it as 1. Now compare 1 and 2. Can you see that DO by OB is equal to these two also, right? Since LHS is equal, we can say RHS is also equal. So DX will be equal to XA and that will be equal to CO by AO, correct? Now these two sides are proportional, correct? DX by XA, which one is that? If you look at this figure, DX by XA, these two, DX by XA is equal to CO. Where is CO? Yes, here, CO by AO. So obviously if you look at here, it means what? This is parallel to this, correct? So as per this we can say XO is parallel to DC. Now since XO, okay, here XO was parallel to AB and that is parallel to DC, we can say AB is parallel to CD. And since one of the opposite sides are parallel, we can say ABCD is a trapezium. Understood? So this is how we have to prove. I hope it's clear and you have understood. Thank you for watching. If you find it useful, do like it, share, comment, and don't forget to subscribe the channel. We'll see you all in my next video. Till then, take care. Bye. Have a great time.